Alright, hello professor. My name is Alex, and this is my video presentation 2. Alright, for this problem we have a bean system, and it's a combined loading problem. It is asking us to find the principal stresses and the max shear stress at point H, right here. Alright, so the first thing we're going to do is draw a free body diagram. So free body diagram. And this distance right here is 6 inches. This distance right here is 12. This distance is 10. And there's 2 forces being acting on it. And this is px, which is 100. And this is fz, which is 125. The force acting down on this is py, that's it, which is 175. This is going to be Rx. This right here is going to be Ry. This is R in the Z direction. And then each one of those is going to have a moment. So, moment in the X, moment in the Y, right there, moment in the Z. This distance right here is 8. Let me extend this. This 12 inches goes all the way to the Z-axis. Right, so there's our our free body diagram at point H. Alright, so the next thing that we're going to do is we're going to calculate the reaction forces given by each load. So here's a 100-pound load, 125, 175. This is a position, this is a force, and you cross both these and you get the moment. So the position is, so 12 plus 6, 18, and then you go up 8, and that's where this 100-pound load is. So that is 18 in the X direction, and then 8 in the Y direction, and then it doesn't move at all in the Z direction. So it's 0. And then the 125 is in the same spot, so it's just the same position. And then the 175-pound is right here, so X is going to be 12, and then it doesn't go up and down, so Y is going to be 0 or J, and then K is going to be 10, because it's this distance right here. And for the force, it's just each one of these 3 forces. So 100 is in the Y axis, and it doesn't move, it's not in the none of these. And the 125 is in the Z, so it's going to be K. Oh, and it's negative, because Z positive is this way, Z negative is the other way. So negative 125. Same thing for 175, it's down here, it's going in the Y. It's on the Y axis. So that's negative 175. And then to get M, it's just R cross force. That'll give you the moment vector. So it's going to be 0, 0. Alright. Now we gotta find the reaction forces. We have to find the reaction forces. For our X, our Y, and our Z. And our moment for X, our moment Y, moment Z. And so the forces in the X is just going to be our 3 forces that are given, which in the X we found was negative 100. And then Y is 175, and Z is 125. And to find our moment is just a summation of the cross that we found right here. So this would be 1,750 minus 1,000, which gives us 750, and it's negative 750. And this is just negative 2,250. MZ is 2,000 right here. 2,100 plus 800. Which gives us 2,900. And so here's our reaction forces. And so now we have to find our stresses in Rx, Ry, and Rz. Yeah. And Rx is on the axis, so it experiences axial stress. This is 100 pounds going this way. And H is on the top. Okay, and to find the stresses in axial force, the equation is, let me write the equation down. Sigma x is equal to force over area, which is represented as P over A. And so our force right here is 100. So 100. And the area is equal to pi r squared. And r, which is given right here, the diameter is 1.5 and the radius is 0.75. So pi r squared, which is 75 squared. Pi 75 squared, so sigma x is equal to 56.59 psi. Okay, so now we're going to do our stress block. Z, then X. Z, Y, Y, X. And because it's sigma x, it's going to be on the x-axis, so I'm going to draw this arrows right here and right here. And those are going to be 56.59 psi. All right, so that's our Rx. Now, going in order, we need to find Ry. And Ry is a transverse shear because the force, if you could see, the force is perpendicular to the beam. Yeah, it's perpendicular. Right here. And Rx, as opposed to Rx, which is on the axis, you know, right here, Ry is perpendicular to the axis. So that's why it's a transverse shear. This is Y, this is X, here's H, and the force is going this way, and it's 175. Okay, and the transverse shear equation is tau xy is equal to VQ over IT. And that is equal to 0. And the reason why is because Q is equal to 0, and that's Q is equal to 0 when it's on the outmost fiber. Yeah, so then this is just 0, so we don't have to do anything. All right, then we move on to RZ. And RZ is also a transverse shear for the same reason. It's perpendicular to the axis instead of on the axis. So we use the same equation. Tau xz is equal to Q or VQ over IT. And then let me draw this really quick. And H is in the middle this time. Yeah, so I was saying V, we already know. Oh wait, so the force is 125. And V is equal to the force, which is 125 pounds. And then Q we need to find. And then T we know is just the diameter. And in order to find I, we use the equation I equals pi over 4 radius, which the radius is 0.75 to the 4th power. So I is equal to, when you plug that into the calculator, it gives you 0.249 inches to the 4th power. And Q is equal to y bar prime times a prime. Y bar prime, a prime. All right. And y bar prime is 4 times the radius, which is 75, over 3 pi. Times, so that's y bar prime, and then area prime is 1 over 2 pi times the radius again, which is 0.75 squared. So when you plug that into the equation, into the calculator, you get 0.28125. All right, so now we got V, we got T, we got I, and we got Q. So now we can find what tau xc is. So V is 125. Q is 0.28125 over I is 0.249, and finally T is 1.5. Right, and that'll give us 94.14 psi. All right, so let me draw the stress blocks. Zx, Zy, Y, X. And we found out it was positive 94. So when it's positive, it looks like this. And then I'm just going to put .14. Yeah, and here's our shear force right here. Right, and it's in the XZ plane. All right, so we found our RX, RY, and RZ stresses. So now we have to find the moment stress. So, and you can look here. So MX is twisting. It's like this. It's twisting. So that means MX is going to be torsion. So I'm doing a cross-sectional view of the beam. This is the force right here. It's twisting, and it's 750. This is Y, and this is Z. So since it's torsion, the torsion equation is tau Zy is equal to T times naught over J, which is equal to the force, which is 750, times the radius, which is 0.75, over, and J is equal to pi over 2 times the radius to the fourth. All right, cool. So type that in the calculator, and Tau zy is negative 1131.27 psi. So I'm going to draw that on the stress blocks. Zy, y, x. And this is negative. So in the last one, it was positive and it looks like this. This one is negative and it looks like this. It's the other way. That's going to be Alright, now we're going to do my. And my is, it's not going to be torsion this time. Because if you twist it it's not going to be twisting like this. It's going to be bending instead, like this. Not twisting. So my is going to be bending instead of torsion. And since it's bending, the force is going to be 250. Which you found right here. And the equation for bending is sigma is equal to my over I. But since y is on the neutral axis, it's always going to be 0. So then this is just 0. So y is 0 because it's on the neutral axis. Alright, now we're going to move on to mz. And mz, same as my, is also bending because it's got to be like this. It's not twisting, so it's not torsion, so it's bending. Oh wait, oops. And this is going to be y. This is x. And h is going to be at the top. Yeah, so it's going to be bending like up and down. Because this is the moment is on the z-axis. So the moment is 2,900 inches per pound. And the equation is the same, so sigma z is equal to my over I, and my is just the force times the radius, which is right here. Over I is equal to pi over 4 times the radius. Oops, not equals to. I is equal to pi over 4 times the radius, which is 75 over 75 to the 4th power. So then you plug that into the calculator, and sigma z is equal to 8,752.34 psi. And I'll put that on the stress block right now. Oh, oops. Oh, wait. Yeah, so this is in the C. And it's going this way too. So this goes. Both these are. All right, so we've done Rx, Ry, Rz, Mx, My, Mz. So, all right, so now we just need to combine them. So yeah, as you can see previously, we had 56 psi on the Rx axial stress block, right here, 56, and we had 8,752 on the MZ bending stress block, right here, 852. And so since they're both on the same plane, you add them together. So here's a combined. I don't know why I did that way. XZ. Alright. So yeah, as I said earlier, you combine the 56 and the 8752. And that'll give you 8,801. Then using the same concept, we add the shear stresses together, which this is 94.14 positive, and then negative, where's the other one? Oh yeah, negative 1131. So, but you have to keep in mind this is positive and this is negative. So when you add those together, the two transverse shears, you end up getting a negative number, which negative looks like this. And that's going to be negative 1037. And that's it when you add them two together. Yeah, I already showed you, but yeah, when you add them together, that's what you get. Let me just do the rest of the stress blocks. Oh, and this is going to be, this is in the X, so this is going to be 8,801 too. Okay, and finally, the last thing we have to do is solve for sigma 1 and sigma 2, the stresses. And we're going to use this one because we have all our forces in there. So the equation for sigma 1 and sigma 2 is equal to sigma x plus sigma z over 2, and then plus or minus, and then sigma x minus sigma z over 2 squared plus tau xz, and that's squared as well. Right, and sigma x is 8,801. Sigma z is just going to be 0. Tau xz we got right here is 1037. So just plug that into the equation. Oh shoot, I think this is 9, not a 1, when you add them together. Plus or minus minus 0 over 2 squared plus tau, tau xz is right here. Oh, and it's because, like I said earlier, this is a negative. I'm going to put negative 1037. It's not going to make a difference, but because we're going to square it, but it is a negative. Okay. After all that, you're going to plug that into the calculator. You're going to get a number here, and then you add them to get sigma 1, which when you add these two numbers together, you get 89.29 psi. And then when you subtract them, sigma 2 is negative 120.6 psi. So that's our sigma 1 and our sigma 2. So that's part of our answer. Now we just have to find the tau max, which the tau max is just find the difference between these and divide it by 2, which is easy. So that's just so 8,929.5 minus negative 120.6 divided by 2 gives us 4,524.5 psi. And that's our tau max. Sweet. It's still recording. And yeah, that's it. So we did the free body diagram. We found the R force, F force, moment force. And we found what Rx, Ry, Rz is. Then our moment X, moment Y, moment Z. Then we added our these together, and then we added our transverse shears together, which gave us 1,037, and then 8,809. Then we just solved for sigma 1, sigma 2, found tau max, and that's it. Here's my signature.